Hello everyone. In this lesson, we're going to go over the point-slope form of the equation of a line. We're going to learn how to make the point-slope form, what we need to create the point-slope form, and then some examples of problems involving the point-slope form. Alright, so what is the point-slope form of an equation? It is an equation which needs one point on the line. This can be any point at all, as long as it's on the line, and the slope of the line. And that's all. That's all you need. To create this equation, say our point is x1, y1, and our slope is m. Our equation will take the form of y minus y1 is equal to m times x minus x1. And both x and x1 are inside the parentheses here. Be careful about that. So if our point on the line was 1, negative 2, and our slope was 3, our equation would be y minus minus 2 is equal to 3 times x minus 1, or y plus 2 is equal to 3 times x minus 1. And we can use any point on the line for this, and it would still get the same valid equation. Okay, let's try some problems. Number 1. Find the equation of a horizontal line that passes through the point negative 10, 3. Now, a horizontal line looks like this. The slope of a horizontal line is 0 because y never changes. You can see that if we graph that, as we move along the x-axis, the y values for the points on the line never change, so m is 0. And we are given the point, negative 10, 3. So if we plug that into our equation, y minus 3 is equal to, and our slope m is 0, 0 times x minus minus 10. Since we multiply this part by 0, the whole thing is 0. So we get y minus 3 is equal to 0, or y is equal to 3. There we go. Let's try a harder problem. Number 2. Find the point-slope form of the equation for a line that passes through the point 4, negative 3, and 2, 1. So if we try graphing that, you should always graph things, visualize them, make it a little clearer. 4, minus 3 would be somewhere around here, and 2, 1 would be around here. So our line would look a little bit like that, roughly. We're given 2 points on the line, so we can arbitrarily choose this one. Remember, we can choose either one, we'll still get the same answer. And now let's find the slope. Our formula for a slope is y2 minus y1 over x2 minus x1, that's rise over run. So if we take this as x1 and y1, and this is x2 and y2, our slope will be 1 minus minus 3 and 2 minus 4, which is equal to 2 over negative 2 or negative 1. Sorry, this should be 4, which would turn this into negative 2. That looks right. Now, taking this as our point, we have y minus y1, which is 1, is equal to negative 2, our slope, times x minus 2. And there's your point-slope form. If we wanted to simplify this further, we could use the distributive property and multiply this out. So y minus 1 is equal to negative 2x plus 4, y is equal to negative 2x plus 5, which turns this into your slope-intercept form. So there you go. two forms, two ways to express this equation. Next problem. This will be our last one. Find the equation of the line shown on this graph here, where the line crosses the y-axis at 0, 6 and the x-axis at 2, 0. So, let's find the slope. M is equal to y2 minus y1 over x2 minus x1. Let's just choose this as point 1, x1, y1, and this is point 2, so this will be x2, y2. So 0 minus 6 over 2 minus 0 is equal to minus 6 over 2, so our slope is negative 3. And let's choose this point as the point in our point slope form. So y minus 0 is equal to negative 3 times x minus 2. Y is equal to negative 3 x minus 2. Ta-da! So, just to recap, for the point slope formula equation, all you need is a point on the line, any point at all, and the slope of a line.